Welcome students, we are given this question and we are expected to find the outcome of this. The question is integral root of x times sine x times dx. Now most of the times people will use the concept of lineate, but I don't want to approach it in that manner. Now what I'm going to do is I'm going to rewrite this as integral root of x times. Now I know that there is an expansion for sine x, which is nothing but x negative x cubed over 3 factorial positive x raised to the power 5 over 5 factorial negative x raised to the power of 7 over 7 factorial plus etc. times dx. Now this entire expansion can be rewritten as, I'm not going to take in root of x, but I'm going to place the equivalent of this expansion in using the summation series. So this is going to be sigma. Now the value of n ranges from 0 to infinity, and since the signs are alternating, this is going to be negative 1 raised to the power of n divided by, I got odd numbers. In fact, this is going to be 1 factorial. So 1, 3, 5, 7. So to generate odd numbers, this is has to be 2n positive 1. And factorial is there, so I'm placing factorial. When n is equal to 0, I get 1. When n is equal to 1, I would get 3. When n is equal to 2, I will get 5. N is equal to 3, I'll get 7. And it goes on. Now this is going to be 1, 3, 5, 7. So I need to generate the same thing. So that's going to be x raised to the power 2n plus 1. And that is it. So this is the series and we got dx there. Now if I were to take this root of x inside, now root of x, I'm going to write it down here, is nothing but x raised to the power 1 over 2. So I need to use that. So when I push this root of x inside, this is going to give me integral sigma n is equal to 0 to infinity negative 1 raised to the power n times x raised to the power 2n plus 1 times x raised to the power 1 over 2 divided by 2n plus 1 factorial, and that has to be multiplied with dx. So this is what it is. Now using the law of indices, which is nothing but a raised to the power m times a raised to the power n is equal to a raised to the power m positive n. Now this is going to be 2n positive 1. It has to be added with 1 over 2. So when I do that, then this is going to be 4n positive 2, right, and positive 1, which is equal to, this is going to be equal to 4n positive 3 over 2. So this is what you've got. So this can be rewritten as, now what I'm going to do, I'm going to bring the summation sign out. So that's going to be sigma negative 1 raised to the power of n divided by 2n positive 1 factorial, and n ranges from 0 to infinity. So the summation is brought out and I'm pushing the integral inside. So this is going to be integral. I've already shown you what happens when 2n positive 1 is added with 1 over 2. So that's going to be 4n positive 3 over 2, and that has to be placed on the head of x as an index. So this is going to be 4n positive 3 divided by 2 multiplied with the differential operator, the dx. Now this is a straightforward integration. So since we know that integral x to the power n dx is equal to x to the power n positive 1 divided by n positive 1 plus arbitrary constant c. This is what is the outcome. So if I were to integrate this, now this has, the exponent is 4n positive 3 over 2. This has to be added with 1 and the same has to be divided. So I want to know what exactly this outcome is. So if I were to take 2 as the LCM, this is going to be 4n positive 3 positive 2, which is going to be 4n positive 5 over 2. So this is the exponent. So this is equal to sigma negative 1 raised to the power n divided by 2n positive 1 factorial. N is stretching from 0 to infinity. Upon integration, this is going to give me x raised to the power of 4n positive 5 divided by 2 over 4n positive 5 divided by 2. Of course, there is an arbitrary constant c. Now this can be rewritten. I can flip it up and I can rewrite this as sigma there's going to be a 2 there. So I'm going to place the 2 here and write this as negative 1 raised to the power n divided by 2n positive 1 factorial. N stretches from 0 to infinity, and this is x raised to the power of 4n positive 5 divided by 2 over 4n positive 5, positive arbitrary constant c. So this is the solution to the question. So on the left hand side, just for the sake of consistency, this is nothing but root of x times sin x dx. So this is the solution for this question, students. Thank you so much.